In this video, we're going to talk about two topics, the derivative of a constant and polynomials, ? Okay, now when I say derivative of a constant, I mean that if our function was just a number, okay? If our function is just a number, then what's the derivative of just a number without an x? And our rule is that the derivative of a constant without any x's is 0, okay? So if I'm given that y equals 12, then the derivative of this is 0. Okay, guess what? It doesn't matter how funky the constant is. It could be the square root of 57. Guess what? The derivative is 0. Probably the thing you'll see in the notes, which is the most confusing, is if they have something, not just the notes but the textbook as well. They might have something like e cubed. Well, e is a decimal. A decimal cubed is still a funky decimal. It's still just a number. So the derivative of e cubed is still going to be 0. Okay, so the derivative of a constant is 0. Now, we're going to tackle the next question, which is polynomials. All right, as you can see, I have a polynomial here, which is f of x equals 4x cubed minus 6x plus 7. And if I asked us what's the derivative without using the limit definition in detail with all the algebra and all the fun stuff, what is it? Well, here's the thing. We know how to take the derivative of this piece. We know how to take the derivative of this piece. And we know how to take the derivative of this piece. Can I just take the derivatives of each piece and glue it together? Yes, you can. This is called the sum and difference formulas. So when you look in our textbook and you see the sum and difference rules, it's basically giving us permission to just take the derivative term by term, and whatever sign is gluing it together still glues it together. So here, if I wanted to find the derivative of 4x cubed, I would have 4 times 3 is 12x squared, right? The 3 comes down, subtract 1, okay? The derivative of 6x, well, the derivative of 6x is just going to be that 6, but it's a minus sign in front. And then if I have a number without any x's, the derivative of that is 0. Now, you'll see in my notes that I'll write plus 0, but technically, that's it, okay? I just write plus 0 in my notes so you know I went through the action of taking the derivative and it disappeared. So that is the derivative of this function. All right, let's try another one. If I had g of x equals x to the 15th minus 4x squared plus 6 root x. That looks fun. Okay, now technically this isn't a polynomial because polynomials have exponents that are whole numbers, not fractional, but this is polynomial-like. And you'll hear me say that in class and in our notes, that it's polynomial-like. So what I'm saying is that this is the same thing as x to the 1/2. So we could just use our power rule on it term by term. Okay, so the derivative of this, so to let everybody know I'm taking a derivative, I write g prime of x. And now I'm going to go ahead and bring it down. Then this is subtraction. I'm going to bring this guy down. Okay. And last but not least, we're going to do this one. So 6 times a half is 3. X to the negative 1/2, right? 1/2 minus 1 is negative 1/2. Now, if we didn't want to take an extra step to rewrite it, we could just take that x to the negative 1/2, move it to the denominator, and there we have it. Now, for those who are wondering why didn't the 3 move down, because it doesn't have an exponent, a negative exponent. This is just the number 3. 3 lives upstairs. This guy, when I took the derivative, was x to the negative 1/2, so it lives in the denominator. So there's our answer. All right, good luck doing the derivative of a constant plus looking at polynomial or polynomial-like functions.